Hello guys, welcome back to Math Zone African Motives. Still working on mathematics N5, working on our integration. Knowing that from our integration, we've got the application of limits that we normally apply, whereby you are given the integral of a certain function of f of x with respect to x, normally written as y here, representing a function of f of x, whereby you've got limits a and b. We can have a condition whereby this a can be infinity and or b can be infinity on a condition like that, which is in this case, let's say we are given the integral this time of an infinity in this case, and we are having a with our f of x in this case, which is the function that we are supposed to integrate. So let me write this in a way that we understand. Remember that if you integrate a derivative, you obtain f of x, whatever that you're going to obtain. So given a function of f of x that you are given to integrate, it simply means you are going to integrate this part and apply your limits from the infinity up to the point A, whereby this infinity, as we know, it represents our upper limit in this case, and A representing our lower limit in this case. So the case is integrate, substitute upper limit minus lower limit, but taking into consideration that once there is an infinite, it means we are supposed to understand the laws or the concept of our limits that we talked about. Remember, I talked about the limits that 1 over infinity is going to approximate to 0. If we are given 1 over 0, this one, it approximates to infinity, whereby this can be given as a constant, whatever function that you have, and also understanding if it is e to the exponent or if it is f of x to the exponent of infinity, in this case, that one is going to approximate to infinity again. So we are simply saying a function of f of x raised to the exponent of infinity is going to give us what? Is going to give us infinity. So these are things that you're supposed to also take into mind or take into consideration whenever you've got a condition whereby you substitute your upper limit, you get infinity over infinity like this. We said on that condition, you are supposed to apply the L'Hopital's rule. Those concepts are supposed to be also taken into consideration whenever you're dealing with what? With your limits. But the only thing that you need to know, guys, is your definite integrals, just the application of what? The application of limits, just like that. For an example, let's say we are given to integrate, in this case, given this limits 1, we are given dx of 2x in this case. All right, this whole expression that we see, if you see the dx on the top, we talked about this on our integration. It simply means we can separate this into the integral of 1 over 2x, simply 1 over 2x in this case. All right, so this can be written as 1 over 2x with respect to x, and also 1 over 2 here. It's a constant, so a constant can be taken outside of the integral, or you can simply leave it like that. You integrate 1 over x, and we know that the integral of 1 over x is a ln. So this one is going to give us 1 over 2, the ln of x in this case, taking our limits now, which is the infinity up to 1. Remember, if we've got the limits like this, upper limit and lower limit, there's no need for us to write the constant of integration in this case. All right, so that means we are going to substitute now the limit, which is the upper limit, so it's half of ln the infinity in this case, minus, we move on to the 1, which is going to be minus half ln of 1, knowing that the ln of 1 is a 0, so this one is going to give us a 0. Ln infinity, guys, we can't simplify this. It's actually going to be infinite, and if we subtract infinity minus 0, that means definitely we are going to remain with an infinity at the end. All right, so the application of these limits is we are simply back to the normal limits that we are used to, the normal limits that we are used to. All right, let me take this into consideration again. We are given the second part again to find the integral, having our upper limit infinity. We have got a 0 in this case, e to the exponent of x dx. All right. same as the part that we have, we just have to integrate, and the integral of e, guys, it repeats as it is. If you're given the integral of e to the exponent of f of x dx like this, it is going to be the first derivative of your f of x over f of x in this case. So if we are to check in this case, we are going to have, all right, I'm applying the derivative of we are applying the derivative concept. Here we are supposed to have e to the exponent of f of x over the first derivative, all right, plus the cost of integration. That's integration. I'm now thinking of the derivatives there, all right. So that means we're going to have e to the exponent of f of x. This is 1, so it's going to be e to the exponent of f of x over 1, which is simply e to the exponent of x. All right, so that means we are going to obtain e to the exponent of x with our limits in this case from infinity up from 0 up to infinity. In this case, we substitute upper limit, which is e to the exponent of infinity, minus e to the exponent, the lower limit, which is 0. In this case, I said e to the exponent of a to the exponent of infinity is actually infinite. So that means at the end here, we are going to obtain infinity minus e to the exponent of 1, which is 1. If we subtract 1 from infinity, it's like we are subtracting nothing. It's like infinity of like we've got this or this number that we see, then we subtract a 1. It affects nothing. It affects nothing to that infinity value or to that value approximated to infinite that we'll be talking about. It affects nothing. So the answer is going to be infinite. So it's not like our answers are going to be infinite. No, guys. Let's take this example. Someone will be thinking, okay, why is it our answers are always infinite? Let us check this example 3 that we are given here. The integral of x squared e to the exponent of minus x dx. These are the most particular exam questions that they will give you. They will give you something like this. All right, so if you have to check, I said integrate, apply your limits. Don't think much, just integrate, apply your limits. As you can check here, this is the application of by parts. And from our by parts formula, we know that the integral of f of x g prime x dx is equal to f of x gx minus the integral of f prime x gx dx like this. All right, you're given this in your formula sheet, so don't worry much. All right, whereby you can choose my f of x in this case to be x squared. So I have to find its derivative with respect to x. Drop the exponent, that will be 2x. I move on to the gx. In this case, on gx, I was also supposed to do the same thing. Integrate this time on g prime x dx, this one. All right, so this is g prime dx, which is the remaining part, e to the exponent of minus x dx. So that's e to the exponent of minus x dx. If we are to integrate this, we are supposed to obtain gx, which is equal to, remember the integral of e, I said it's e to the exponent of f of x over the derivative of this f of x, which is -1. So that means we are going to obtain negative e to the exponent of minus x, which is same as 1 over, which is same as 1 over, which is same as -1 over e to the exponent of x. All right, so this information, we are going to substitute this whole part that we have here. This is where we are going to substitute. So we're going to have the integral. All right, this whole integral is going to give us f of x, which is x squared. So we're going to have x squared times gx. Our gx, we said it's minus e. That's minus e to the exponent of minus x in this case. All right, minus. All right, so we move on here, minus the integral of, so we've got the integral of in this case, so this is the integral of f prime. So that's f prime x, which is 2x in this case. So we're going to have 2x by gx dx, our gx, which is negative e to the exponent of minus x like this dx. So this is what you're going to have, not forgetting our limits in this case. All right. Checking on this part that we have now, we can just simplify before we talk about a lot of things here. So this one is going to give us negative x squared e to the exponent of minus x. All right, we've got a negative that is inside here and this negative. So that one is going to give us a positive. So we're going to have positive. We can take even the 2 outside, or you can just leave the 2 inside, does not affect. So we're going to have 2x e to the exponent of minus x like this with respect to x. So we are going to integrate this part that is inside this bracket, but not forgetting our limits infinity and 0. All right. If we are to check what is inside here, there's a repetition. This part that is inside, we are supposed to integrate. As we can see, there's an integral sign here. So this part we are supposed to integrate with respect to x. But we can't integrate directly. We're back again to the same concept like what we have in this case, whereby these two were multiplying each other. So meaning to say we are supposed to apply again our by parts concept in this case, whereby we are saying if this one is going to be this and this. So we need f of x just like the previous part. So which part is going to represent our f of x? Our f of x this time will be equal to 2x. We need its first derivative. What is the first derivative of 2x? That is going to be a 2, all right? From this part, we are going to need gx, which is from g prime x. But if you are to take a closer look, this is the remaining part, e to the exponent of what? X gx, which is the same part that we had before. So you're supposed to have g prime x dx. It's a repetition, e to the exponent of minus x dx, this one. So this one is a repetition. So meaning to say our gx is going to remain as what? Minus e to the exponent of minus x. This one is a repetition from this part that we had. All right. So knowing that we are applying by parts concept on this part here, so we are going to have the first part is going to remain as it is, this one. So we are going to have minus x squared e to the exponent of minus x plus whatever that we're going to get from this part of our integral. And this part of the integral is going to give us what? This part. That is where we apply. Remember, we said we are going to apply our by parts. So we're going to have f of x, just like what we did previously. F of x, whereby our f of x this time is 2x. So that's 2x times gx, our gx, which is negative e to the exponent of minus x, all right, minus the integral of, so we're going to have the integral of f prime x, our f prime x, which is 2 in this case, so that's 2 gx dx. So remember our gx, that's negative e to the exponent of minus x with respect to x in this case. So this is what we are going to have at the end with our limits infinite and 0. So we're applying by parts twice. We did the first part, we tried to apply by parts, but whilst we are integrating again, we are seeing that there is a need for us to apply by parts. So we have to apply this formula again. So this is where we are at this stage, whereby we have applied our by parts. So now we are going to integrate this part that is inside by, okay, we can just simplify first. This one, we can have minus x squared e to the exponent of minus x, all right, can expand brackets plus, and this part here, it's plus times a minus, so there's a minus x here, there's a minus here, so it's going to be plus times minus, which is a minus, so we're going to have minus 2x e to the exponent of minus x, all right. We move on here, there is a minus that is here, and there's a minus here, so it's going to be minus times minus, which is a plus, times this plus here, so it's going to be a plus, the integral of, so we are left with the 2 in this case, so we can take this 2 outside of the integral. We remain with e to the exponent of minus x with respect to x like this. All right, so that's now we can integrate direct. This one can be integrated. Remember the integral of e to the exponent. We talked about this integral before. It gave us minus e to the exponent of minus x. It's a repetition, this one. So we are going to obtain minus e to the exponent of minus x if we integrate this part. So that means we are going to have minus x squared e to the exponent of minus x minus 2x e to the exponent of minus x. Then we are going to have plus, all right, before this one, remember we said the integral of this is going to give us minus e to the exponent of minus x. We did this integral before, but it's going to be multiplied with 2. So it's 2 times negative, which is going to be negative 2 e to the exponent of minus x like this, okay? There's no need for us to use the constant of integration. At this stage, this is the most important part. In order for you to apply the limits here, try by all means to get rid of these exponents that we see. To have fractions, it's best we express these in form of fractions so that we can apply our limits properly. So let us have these as fractions. So we are going to have to the exponent of negative means 1 over. So we're going to have minus x squared over e to the exponent of x. Then here we are going to have e again. So it's going to be minus 2x over e to the exponent of x. We have got e to the exponent of minus x, so it's going to be minus 2 over e to the exponent of x like this, with our limits here infinity and 0. Remembering that once you apply the limits, you are now back to the application of limits where there is infinity. So we're going to substitute infinity, which is our upper limit in this case, and this being our lower limit. So our upper limit is infinity. So here we are going to have infinity. Remember I said infinity. If you raise infinity to a certain exponent to be infinite, e to the exponent of infinity is also infinite. So this first part, it is giving us infinity over infinity, infinity over infinity like this. And I said, whenever you are dealing with the limits and you obtain an infinity over infinity like this, you are supposed to apply the L'Hopital's rule. That is what you're supposed to have, whereby you have to differentiate, find the derivative of the numerator, which is going to give us minus 2x, find the derivative of this denominator, which is going to give us e to the exponent of x in this case. That is the derivative that you're going to obtain at the end. All right, but if we check here, we differentiate again, find the derivative of this, because if we substitute here, we're going to have infinity over infinity again. So we're supposed to find the derivative again, which is minus 2 over e to the exponent of x. So this one now can be substituted, whereby if we substitute our infinity now, this part, if we substitute infinity here, it is going to give us what? Minus 2 over infinity. Remember, k over infinity, guys, we say this one gives us a 0. So meaning to say, if we substitute the upper limit here of infinity, we are going to end up having a 0. So the simplification part is only affecting where you obtain infinity over infinity. You apply the L'Hopital's rule. So let us move on to the other part. We substitute again infinity here. It is going to be infinity. E to the exponent of infinity, it's infinite. So this one was going to also give us infinity over infinity. So we are supposed to apply our L'Hopital's rule again, because we are obtaining what? Infinity over infinity. Remember, your L'Hopital's rule, you find the derivative of 2x in this case, that will be a 2 over the derivative of e to the exponent of x, it's e to the exponent of x. Substitute our limits, so it's going to be 2 over e to the exponent of infinity, that's infinite. And you said a constant over infinity gives us a 0. So we are going to obtain a 0 in this case, all right? We do the same thing here, e to the exponent of infinity, that will be infinite. And 2 over infinity gives us what? Gives us a 0. So we're going to subtract a 0 in this case. So as you can see, guys, this whole part was going to give us a 0 if we substitute infinity. So the substitution of infinity, you apply the L'Hopital's rule whenever it gives you infinity over infinity, so that you get the exact value. But now we have to subtract our lower limit, because here we're working with the upper limit, which is infinite. Now our lower limit, it's a 0. So we have to substitute 0 in place of x. So if we substitute a 0 here, that would be a 0. Once here, it will be a 0. E to the exponent of 1 is what? It's a 1. So once we've got 0 divided by 1, that means we are going to obtain a 0 there. We substitute a 0 here. As long as there is x in the denominator giving a 0, it means we are going to obtain a 0 there. All right, so that's minus 0 here. We move on to this part, e to the exponent of x. Our x is now a 0. E to the exponent of 0 is what? It's 1. So this one was going to give us minus 2 over 1, which is minus 2. So that's this whole part is going to give us a 0 minus. This whole part is going to give us 0 minus 2, which is minus 2. So that's 0 minus minus 2, which is going to give us a positive 2. So that's the application of your limits. They are testing you back to your chapter 1. They are taking you back to chapter 1, working of limits. That is how they play around this type of a question. So we shall see more questions. Also check, if you check the August 2023 exams, they have a question which was similar to this part, where they wanted us to apply the limits, and at the end, we end up applying the L'Hopital's rule wherever there is infinity over infinity. So you just have to take into consideration your limits. Don't forget to revise your limits, they are also necessary in this case because they are now applied whenever we have this infinity over infinity concept. You have to apply the L'Hopital's rule. So that's what we had, guys, from Meson African Motifs, working on mathematics N5. Till we meet again.